Hello. Imagine your computer's memory as a big house with rooms for different things. Some need a small space, others a big one. In this video, I will explore this memory house to show why numbers and letters live in a different sized rooms. So the topic I am going to look is data types. So before I start more detail about data types, let us see how if I want to add two numbers. So for example, I want to add two numbers 2 plus 3. So you will simply say 2 plus 3 is 5. But is this sufficient when we are dealing with the computer programming? So we are going to deal with computer programming in the sense what? We are going to ask the computer to compute this 2 plus 3 and give the result to us. Okay, in simple words. Right? How does it do? So we have to provide an input for that. We have already seen in the previous classes. We have to provide input for that and give the proper appropriate operators, and when we have to compute it, then based on that computation operation, it will give the output to you. Now the point I am trying to tell here is always computer deals with memory and processor. Means what? Whatever you are going to do, whatever you are going to store, whatever the data you are going to operate on, that must be first stored onto the memory. Then from that memory, the memory processor is going to retrieve it, and after retrieving it will compute it and give the result back to the output devices. You can see this process in the previous classes I have mentioned already in the topic called computer architecture. Right. So now you see here. So data types basically they specify type of data a variable can hold. What does it mean here? What is the meaning of variable? Variable is basically a named storage location. As I said just now, we are going to deal with the memory and processor when we are computing. Every data must be stored in the memory. So for that, for each data we store in the memory, we give a name for that. So that name we call it as a variable. Okay. So whatever the name we give, it is a variable. And for each data we want to store, we'll give a variable name. And that is retrieved by the CPU for performing whatever the operations we want to do. We'll see more detail on this. Okay, for now you understand variable means it's a memory location, named memory location, and this is having some value stored in that. Okay. Now what is data type? Type of data. Okay, understand this word. Type of data, a variable coin word. Means what? There are different types of data. So that each variable going to hold it. Okay, I'll give the more detail on it. So now apart from that, these data types determine the size and range operations that can be performed on a variable. Okay, now it is not only mentioned what is the type of data. I'll tell you in a minute what is the meaning of type. Apart from the type, it is also going to tell you what is the size of the data, and also what is the range of the data, and also what operations can be performed on this particular variable. So this definition you keep in mind. I'll come back to you this again and again here while we are dealing with the data types. Now there are basically different data types. So we call them as one type, it is a primary data types, other one is a derived data types, next is user defined data types. Okay. So primary data types basically the name such as character, integer and float, void. Okay, we'll see in detail these important data types here. So what is that? Character is one, integer is other data type, float is other data types, and then void is no data type basically. And second category is derived data types. In the derived data types, it comes, the list goes like this: arrays, pointers and functions. So these are the derived data types. So these derived data types basically they form a new data type using the primary data type. We will see these details when we are dealing with the separate topics. There are separate topics on arrays, there are separate topic on pointers and functions also. How they are going to use these primitive data types while defining the new data types. Okay. We'll see details about derived data types and also user-defined data types. User-defined data types such as struct, union, enumerate, and type def and all. So these are the entire data types and the important, you can say, major data types that are classified in a C language. So we'll see now only primary data types. So primary data types, what I said, character, integer, float, and word. I'll give in detail what does it mean, and I'll also explain you with example. So first let us see. So these are the data types applicable to 32-bit systems. I'll tell you in a minute what is why we are emphasizing on the 32-bit systems, 32-bit architecture I am saying. So first type is character data type, and this basically it takes 1 byte. I already mentioned what is the meaning of 1 byte means. It is 8 bits. Okay, up to 8 bits. This is 1 byte means 8 bit. Means it can take size of this character is if you declare any variable as a character variable, it can store only 8 bits. That means 1 byte. Example how you can declare a variable type A as a character is as follows. You can see here. So character is a keyword that indicates this grade is a variable, this is a variable, grade is a variable, okay, and this grade is a variable, and this character is a keyword that indicates type of the data. So what is the type of the data? What is the variable I am mentioning here? Grade. So grade is a character type. Means what? I can store only a character here. Usually characters are enclosed within a single code here. You can see single quotes, within the single quotes a character A. So for each character, that means what? It is going to store oddly 1 byte. This character is represented by 1 byte. That's the meaning of it. Simple declaration. I'll tell you more detail about variables. Okay, now I am looking only on the data types. So first one is a character data type. So what are the range of values? I already mentioned it. It says the type and there's size and also range. You can see here what is the range of these characters that are approximately, that is minus 128 to 127 through 0, minus 128 to minus 128 to 127 through 0, or else 0 to 255. This we call it as a unsigned characters, we call it as a 0 to 255. So we have already seen in the previous class saying that so all the numbers between 0 to 255 can be represented by a 1 byte. Okay, 1 byte means it is 8 bits. So 8 bits. So how, for example, if I want to represent 0, it is just simply all 8 zeros. This is, let us say these are 8 zeros. And if you want to represent 1, we can represent all zeros. Last 8th bit will be 1. These are all 7 zeros. And then 8 1 will be 1. Similarly, 255 will be all ones. All 8, totally 8 ones. Then 8 ones. Right? So this is about data type. Character data type. So next is we have integer data types. So this integer data type takes up to 4 bytes. When I say 4 bytes, it is 4 into 8 bits. Okay. So how we can declare a variable as an integer is like this. Int keyword followed by, let us say, some variable name age, and I am assigning a value int 17. So 17 is an integer. Right? So this is how we declare a variable integer in C program. So what are the range of values? Means you can store the values between this left hand side one to the right hand side. Okay, you can store the value any range between these. Means this much bigger values can be represented using a integer variable. So as I said, only up to 255 values can be stored in a character. After 256, 257 means it is not possible to store in a character type variable, because it's after 255 what? More than 8 bit. More than 8 bit, this size is not allowing. That's the meaning of it. So similarly, 4 byte means what? Almost it is 4 into 8 bits. Okay. So 4 into 8 bits, that's why we have range. I can represent any number between, I can store, in the sense represent means I can store any value between these two ranges in this particular variable age, as age is declared as an integer variable. So similarly, there are other types. I'll tell you in a minute what is the meaning of unsigned and all. There basically we call it as a access specified, modifiers, we call it as a type modifiers. I'll tell you in a minute. So now unsigned I am saying here it is a signed. By default minus 2 plus means minus some number 2 plus some other number. This indicates they are unsigned. So they are signed. Signed means there is a minus is there, plus is there. Now here it is unsigned int. So it is simply double of it. What in the earlier some 2 something, and here it is a 4 other one. Right? 0 to this is the range of it. So it could be in crores somewhere. So this is a number, this is not important. You just remember 4 byte is important. 4 byte. This number you don't need to remember this. Okay. So only thing is whether into takes a 1 byte and 2 byte or 4 byte. This we have to say. Unsigned also takes a 4 byte. So similarly we have short int. I'll tell you the color, the words in pink color. I'll tell you in a minute. Now for understand. So you can see here unsigned 4 and short I am saying int actually it was a 4. I am reducing it to 2. So 2 byte. 2 byte when I say it is minus some 32,002 plus 32,000 means all the values within these two ranges can be stored in a variable of type short int. Short int, let us say a equal to let us say 45 30,000. 30. This is possible, right? So similarly we have other data types. So that is a long int. Again I am saying long int is actually 4. Long int I am saying it could be even 8 also. 8 byte also. So that's why it's system dependent. Long can be 4, sometimes long can be 8. So it depends on the architecture, system architecture. Now next category is float. These are the main character, int and float. So float is basically 4 byte, right? But it use it to store the precision values. So what is the range? What is the meaning of it? Precision means the values with decimal point can be stored in the float type variables. So here characters, here integers, here values with floating, decimal points. This we call it as a float type, and float as type variable can store up to 4 byte. Okay, you can see type of data. This is one type of data. This is another type of data. Int is another type of data. Float is another type of data. So point here is this float can store up to 6 to 7 digits precision. I'll give the demo also for this explanation on this. What is the meaning of 6 to 7 digit precision in a minute. So next we have double, and this basically stores 8 bytes. You see here it is a 4 byte, float is a 4 byte, whereas double is a 8 byte. Now what does it mean? It is also going to store the point, values with decimal points like this. 3 point something or any other value, but the point here is this is going to have 15 to 16 digits of precision. So as I said, the difference between float and double I am going to explain in a minute with a demo example. What is the meaning of digits precision? Now understand, for both float and double will store the values which looks like which ends with a decimal point. Okay, which is having decimal point. Now long double. So as I said, long and all these words in pink color are having different meaning. I'll tell you in a minute. So this long double, it is only double, but I am increasing instead of double 8 to it is almost it's 10 to 16. This is also system dependent. Likewise, there can be many other. These are the important data types which are typical for the 32-bit systems. So this size of the data types, size in the sense what? Either it's int is a 2 byte or 4 byte, or float is a 4 byte, or double is a 8 byte or not. These are basically varies based on the system architecture. Means it could some 32-bit systems, byte meaning it could be 2 byte, and integer meaning it could be 2 byte for 16-bit systems, for example. Okay, for 16-bit systems, as I said, int variable could be instead of 4 byte, it may be 2 byte. Similarly, for 32-bit systems, it may be different. For 64-bit systems, it may be different. And not only system architecture, it also depends on the compiler is being used in that system. So for running the C program, compiler dependent and also system architecture dependent, these sizes, whether int is a 4 byte or not, is decided by the type of the system. That's why I am saying for a 32-bit system, these are the sizes for various int, character, int, float, double. These are very important. These four, character, int, and float double, we call it as a primitive data types. Right, now we look into this keywords in pink color, that is a short, long, unsigned. As I already told you, they are basically type modifiers, means if some data type is there, that type is been modified, altered. Okay, so basic data type, whatever is primitive data type, those data types are altered. Let us see how. So signed meaning is it allows basically whenever in front of int, int is basically by default it is int and character as signed only. Signed meaning what? It can take values, negative values, some 2, 3, 4, 5, 6, okay, and positive values, let us say just 2, 4, 5, 6. So these all values can be stored in int. Similarly for character also, minus 127 to minus 127 to plus minus 128 to plus 127, this can be stored. That's why by default int, float or int and character are signed. So by default means if you don't mention signed int, that's the meaning of it. Signed int, it's okay. Okay, if you don't need to mention signed int and signed character, some variable a, let us say ch, like this you don't need to mention because it by default. So next we let us see unsigned. So unsigned meaning is non-negative values. Means what? Non-negative values means what? Whenever you mention unsigned and some into a equal to some value, let us say 10, whatever it is. So this meaning is it takes only positive values. Only positive values. As I told already, positive range is what? Some 0 to it is 4 to something, somewhere around 42 crore or lakh, whatever, doesn't matter the number, right? So this is the range it indicates. Similarly for short, so it basically reduces the size of the int. So whenever I mention short int, you can see here in the previous example. So here you can see short, actually int was a 4, now it has been reduced to 2 because of the short. So size I am altering here, that's the meaning of it. And similarly we have long, so this is increases, short is reduces, long increases the size. So basically it could be int or double, that size is increased. So similarly constant keyword, so this is basically makes the variable unmodifiable. What does it mean? Whenever you include the keyword constant in front of int and some variable max, so whenever you cannot store this, you cannot change this max value. Means what? Always whenever you refer max, it is 100 only. So if I want to try to modify this max equal to, let us say max equal to max plus 10, if you try to do this operation, what I am trying to do here, I am adding 10 to the max, previous max, and I am trying to modify the current max with the new value. That means what? We are trying to do, let us say 110. We are trying to store 110 in the max variable. This is not permissible.